Hello, this is the lecture number 6 for the chapter sets of class 11th, and we are starting with exercise 1.5, in which we have to find the complements of the given sets. And we have discussed in the basics of this chapter to how to find the complements of the sets. I'm taking the question number 3 of this exercise because the questions given is in the set builder form. So when you have to find the complement or intersection like this, you have to first of all convert into the roster form. So it is given that universal, because to find the complement of set we must have the universal set. So in question number 3, the universal set is given as the natural number, and in the first part the set A is given as the even natural number, so 2, 4, 6, 8 and so on, and its complement will be all those elements which not belong in this set but in universal. So it will be 1, 3, 5, 7 and so on, which is the set of odd natural number. So you have to write the answer in this set builder form because the question is given in the set builder form itself. In the fourth part, it is given that x is the natural number divisible by 3 and 5. So x is a natural number, which is fourth part, sorry. So it is x is a prime number. So 2, 3, 5, 7, 11, 13. You have to find the complement of this. So it means those elements which not belongs to in this set but in universal. So it will be 3, 4, 6, 8, 10, 9, 10 and so on. Means x is a composite number including 1. Why I'm including? Because the prime number and the complement of this will be composite, and because 1 is neither composite nor prime, so I have to write here including 1 also. So like this you can do the question number 3 all parts. In question number 4, you have to prove the De Morgan's law, which we have done earlier in 2 ways, by the Venn diagram as well as by taking the examples when we are discussing the complements of the sets. So here also I will prove it. The universal set is given as 1, 2, 9 natural number. The set is A given as 2, 4, 6, 8, and the set B is given as 3, 2, 3, 5, 7, 9. Now you have to prove that A union B whole complement is equal to A complement intersection B complement. This is the De Morgan's law. On second part is in place of union, if we have intersection here, then you have to bring union here. So we have to prove that A union B whole complement. So it means first of all you have to find A union B. So it will be 2, 3, 4, 5, 6, 7, 8. 2, 3, 4, 5, 6, 7, 8 is the union of these two sets. Now the complement of this will be those elements which not belong to this A union B but in universal. So 1 and 9 is not there in this. So 1, 9 is the A union B ka whole complement. Now you have to find A complement intersection B complement. So A complement those element which is not in A but in universal. So it is 1, 3, 5, 7 and 9, and B complement those not in B but in universal. So it is 1, 4, 6, 8, 9, and the intersection of these two is common to this. 1 and 9 is common to these two, so they are equal to each other. So we can say that A union B whole complement is equal to A complement intersection B complement. This is the De Morgan's law. Similarly, we have to prove that A intersection B whole complement is equal to A complement is equal to B complement. Union B complement is also a De Morgan's law. So first of all, find A intersection B, that is element common to A and B is only 2, and the complement of this will be 1, 3, 4, 5, 6, 7, 8, 9. Then A complement union B complement. The union of A and B, A complement and B complement is 1, 3, 4, 5, 6, 7, 8, 9. So these are the element of this A complement union B complement, which is equal to this. So therefore A intersection B whole complement is equal to A complement union B, which is the De Morgan's law. Now in question number 7, you have to fill the blank. A union A complement is equal to universal. We have discussed in the basics. Now if we find the total element of A, and those which is not in A will be equal to its universal. Now empty complement is equal to universal, you know it, and universal intersection A will be equal to A. Now A intersection A complement. Now A and A complement means those elements which not in A, so there is no element common in these two, so it will be empty. Now universal complement will be equal to empty, and empty intersection A will be equal to empty, like this. Universal complement empty, empty intersection A is equal to empty. So this is the exercise 1.5. 5 in which you have to find the complements only. Now in exercise 1.6, based on the cardinal number formula which we have discussed in the basics, cardinal number formula is cardinal number of A union B is equal to cardinal number of A plus cardinal number of B plus cardinal number of A intersection B. So this is the cardinal number formula. In question number 1, directly you have to replace these values and the given values in the set. The cardinal number of 17 A is given, the cardinal number of Y is given, the cardinal number of union is given, and the cardinal number of A intersection B you have to find out in question number 1 of 1.6. In question number 2, if x and y are two sets such that x union y has 18 elements. So the number of element in x union y is given as 18. The number of element in x is given as 8. The number of element in y is given as 15. And you have to find the number of element in x intersection y. So you use this formula. Cardinal number of x union y is equal to cardinal number of x plus cardinal number of y minus cardinal number of x intersection y. Replace these values in the formula, you will get the x intersection y. In question number 3, it is a word problem. In a group of 400 people, 250 speak Hindi. So number of person who is speaking Hindi is 250, it is given, and the number who speak English, the number of person who is speaking English is 200. Then how you have to find how many persons speaking both the languages, that is Hindi and English, you have to find, and Hindi union English, the how many person, the total number of person is given, that 400. So use this formula, cardinal number of Hindi union English is equal to cardinal number of Hindi plus cardinal number of English minus cardinal number of H intersection Hindi intersection English, means the number of person who are speaking both the languages. So replace union H or E, you will get Hindi intersection English, that is the number of person who speak both Hindi and English. You have to write in the end in the statement. Now this question you can do by the Venn diagram also. You know how to draw the Venn diagram. The rectangle denotes the universal set. The two sets here denote H and E, these circles, and replace here A, B and C. Now what does A means? A means the number of person who is speaking both Hindi and English. A plus B means the number of person who is speaking Hindi. A plus C means the number of person who is speaking the English, and it is given that the number of person who is speaking either Hindi or English is, that is A plus B plus C, is given as 400. The number of person who is speaking Hindi, that is A plus B, is given as 250. The number of person who is speaking English, it is given as A plus C is equal to 200. You have to find the value of A, which can be obtained by solving these three equations using the substitution method. You will get the value of A, and in the end you have to write in the statement, that is the number of person who is speaking both the languages is 50. Now try to do these types of question in using the Venn diagram, because it will, when it's become somewhat easy than the this cardinal number formula. In question number 6, it is given that there is a 70 group of 70, 37 like coffee. This I taken as coffee, that is A plus B is given as 37, and 52 like tea. T is A plus C, it is given as 52, and there is a group of 70 people, so A plus B plus C is given as 70, and you have to find how many people like both tea and coffee, that is you have to find the value of A, as we have done in question number 3. So simplify these three equations to get the value of A, B, C. Rather you have to find only the value of A, which is coming out to be 19. So in the end you have to write that 19% like both tea and coffee. 19% like both tea and coffee. In question number 7, it is given that in a group there are 65 people, 40 like cricket. So like this, draw the Venn diagram. A plus B is given as 65. There's a group of 65, that is A plus B plus C is given as 65. Now A plus B is 40, that the number of person who like cricket is A plus B, it is 40, and the number of person who like tennis is A plus C. You have to find, and the number of person who likes both cricket and tennis is A, or rather they play it. You read the question. They like how many person like tennis only, and how many person like tennis you have to find. Now what is given? A plus B plus C is given, A is given and A plus B is given. You solve these three, putting the value of A in this, you get the value of B. Replace the value of A and B here, you will get the value of C. That is, C means the number of person who like only tennis, not cricket. And the number of person who like tennis is A plus C. This you have to find. The number of person who like tennis is A plus C, and the number of person who like tennis only is C. You see in the diagram very carefully. In question number 8, it is given that in a committee 50 speak French. So again, draw the Venn diagram: French, Spanish, ABC. It is given that 50 speak French. So French is A plus B. The number of persons speaking French is A plus B. It is given as 50. 20 speak Spanish, which is A plus C. It is given as 20. And 10 speak both. That is the value of A is given. It being asked how many like at least one of the languages. How many like at least one of the languages means the number of person who speak either French, either Spanish, or both. That is A plus B plus C you have to find. So A plus B is 50, A plus C is 20, A is given, put the value of A here, you will get C, put the value of A 10 here, you will get B. Number of person who speak at least one of the languages, A plus B plus C, replace with values, you will get the total number of how many person are there, or how many people like at least one of the two languages. It can be asked how many person speak none of the language. So how can you do it? You subtract A plus B plus C from the total what is given. From this you'll get how many speak none of the language. You will get this type of question in the miscellaneous exercise. Okay, we'll discuss the miscellaneous exercise in the next lecture. Thank you.